Getting right back into calculus. So calculus, we are starting to do derivatives. There's rules for derivative. It feels like there's actually just one rule, but all the other nitty-gritties come into it. I want to do these sums by taking exponent times coefficient minusing 1 from the exponent. What? So there's rules. First one, the rule is I first have to deal with the root. You cannot differentiate unless you've done the root. Please do not say, oh, but I know the differentiation of 2 and it's 0. Because you cannot do that while you're still taking the x out of the root. You have to leave it as is until you can do the whole thing. What happened there? The rule is taking it out of the root into exponent form. It is exponent 1 over 2. Never something anything else. Now it's differentiatable. Very, very horrible word that doesn't. I can differentiate. It's in the right way. Now I can say the answer for the differentiation is 0, and this one will be the half times the minus 1 is?
Minus a half.
And x to the?
Minus a half.
Can we write this on different ways? Yes. Don't. What's wrong here? The notation should be what?
dy over dx.
Okay, same. There's the expression y in terms of x. Now I have differentiated y in terms of x. Please don't have it there already, then it's wrong. Don't have it in the next step. Don't have the 0 there while you're doing this and then you do that. You're going to get marks deducted because you should do it all at the same time so that the notation can be right. Next one, what's wrong with it? Why can't I just differentiate? Because of the brackets, it should be separate terms. No roots. No denominator with an x or a variable in it. Okay, so for this one, we first need to go write it as, and there's choices to be made. Good choice is to do the difference of squares first, then multiplying in the x. Could we not have put the x in first?
We could have.
But then you would have had a longer sum. So this would have been x squared plus x. Then you had a 2-term times a 2-term to go and work out again with FOIL. And it's quicker the way that we did it. So choices make your life easier or harder. So now I'm done. I'm not done. I've just simplified the thing so that it is able to be differentiated. So if I do the derivative, it's going to give me derivative equal to
3x squared.
3x squared minus 1. Are you getting this?
Yes, ma'am.
Exponent times coefficient is 3. Take away 1 from the exponent. Exponent 1 times the negative 1 is negative 1. Take away 1 is going to be x to the 0. That's why it's just 1. Are you all with me? What does this represent again?
The gradient.
The gradient. You don't know what, where, when yet, but this will be the gradient of this original thing, which is going to be a cubic graph, will be the gradient at any point will be able to be calculated with the formula. So it's not going to be the same gradient everywhere. It's depending on the x. Wherever the x is, at -1, -6, wherever, it'll change. So just in the back of your head, what does derivative give you?
Gradient.
Gradient. Okay, next one is not differentiatable because we still have to write it as x to the minus 1. Then we can say exponent times coefficient. So that differentiation or derivative is 4 plus 4
x. It's the part -2.
-2. I'm so glad nobody said 0. Because -1 take away another -1 is going to be -2. Don't do anything to that. It is true that this is 4 over x squared. But don't take it back again. Leave it. Next one could have been a little bit of a problem.
Get rid of the roots.
Get rid of the root how?
No.
By doing what?
One by one.
Can I just do this exponent thing times?
No.
Okay. So what's going to happen to this exponent then? Where do I put the exponent? On every one. 2 over 2.
Yes.
Because of the?
Oh.
All of those rules only apply if it's everything times. All the time. And you can't take it out of the root if everything's not times. I could put the whole thing to the power of a half, that's true. But then what? Can I then time it in?
No.
Still you can't time in the exponent because there's negatives and positives. Are you with me here?
Yes, ma'am.
So this was a tricky one. And the trick is this can factorize
Yeah.
into what? X minus 3 and another x minus 3, which is going to give you x minus 3, which solves my problem. Now I can say exponent over the root side, which will give me x minus 3 to the power of 1. What's this? Is this differentiation yet? Not at all, but it tricked you. Only thing you could do is to factorize so that you can get an exponent that you can put in there. So it's a little bit higher level. Not much, but a little bit. Is this done now?
No.
This is still just y. I like to put the y there so that you can remember. Don't start doing something with your notation until the right time. I've done no differentiation yet. What is the dy dx? What is the gradient of this line?
1.
1. You see it?
Yes, ma'am.
Only with a straight line, because parameters and all that stuff don't have a constant gradient. But you can see the constant gradient here. But let's do it old school now. Exponent times coefficient is 1. Take away from the exponent, x to the 0 is then 1. And the differentiation or derivative of a constant number, y again. Because if you would go and write down y to the negative 3 and you want to sketch it, it's going to be a straight line with a gradient of 0. So the differentiation or derivative of 3 is 0. If you want to, for now, for practice purposes, write there plus 0 all the time, it's fine. But the answer is 1. Okay, number F.
Okay.
What do we do?
We take out the denominator to the top.
Take the denominator to the top. What are you going to do with it then? X to the minus 1. What's wrong here?
What?
It's not one.
That's true.
Okay.
But then what?
Alright.
Okay? You can do this, but you've got to remember that it's times with both of them, which will make them 2x to the time it. Because when you time, you plus the exponents. And then that one multiply. That's fine. But most kids make a mess up of that. Better way of doing it was to say, put them each on their own denominator. What was this thing's name? Y. Sorry, I missed the Y. There's no notation there. Okay? Now it's not looking the same as that one yet. Next step, this will be when I divide, I subtract exponents, and this will still be x to the minus 1. So there's nothing wrong with that, but kids mess this up. If you want to take it to the top, it's the whole thing in a bracket times with that number, which you time in them. You with me?
Yes,
And it's only applicable for certain cases. Have I done any differentiation yet?
No.
So now I'm going to do dy dx, because you can't decide, I don't like y, I'm making it fx. And then it's f dash. Can't do that. Then this one would be 6x squared plus perfect sum for a matric paper. Perfect. 4 marks. Writing it correctly, 2 marks. Doing the differentiation, 2 marks. Easy peasy marks.